Okay, so today we will continue talking about networks. I'd like to focus on the security issues today. So last time or last lecture, I finished talking or showing you how we can intercept message using quite simple software. And even you send your password and your password seems to be invisible because there are some asterisks in field where you enter your password. In fact, depending on protocol which is used to send it via network, it can be intercepted and easily decoded. So most services uses encrypting methods, and this method is called TSL-SSL. So if you connect to server or web server using HTTP protocol, it is not encrypted. So everything is sent in plain text. If you use HTTPS, it uses TSL-SSL. So now I'd like to tell you several things about how it works. So a little math here. So okay, so now I'd like to tell you something about the basic or the most essential thing in TSL-SSL protocol. So about how data is encrypted. So the key thing is that this protocol uses RSA encryption, so public and private key. And now I'd like to explain how it works. So we have two prime numbers. These numbers are large, yeah, so they can be about 128 bits. So they are large, and it's not they are not easy to guess. Okay. So then we calculate something. So we calculate the we multiply these numbers. So we calculate n, and we calculate something which is called Euler-Toitent. So we calculate the multiplication p minus 1 times q minus 1. And then we calculate greatest common divisor for Euler-Toitent. And so we calculate, in fact, two values, which are denoted as E and D. So look, we get two values or two pairs. First pair consists of the value of n, so the multiplication of two prime number, and private key consists of pair of N and D. Yeah, so we have N and E and N and D. When we have N, it's not easy to guess what are the P and Q because it's huge value. As I said, it can have more than 128 bits. Sometimes these numbers are even higher. They have 1,000 bits. So they are very huge. And then when we have these two pairs, there is a mathematical rule we can apply. So look, let's assume that we have data. So they are denoted as NI. So we have a block of data, and we calculate a modulo with N. Okay, this block of data is exponentiated. Yeah, so we have to exponentiate it to power e and calculate modulo N. So look, if we perform modulo operation, okay. Okay, so if we perform modulo operations, so let's say we have 11 modulo 5. And in this case, the result is 1. Yeah? The same if we take another value, so 12 modulo 5, the result is 2, and so on. But look, so if we apply encryption like this, and we get 1, 2, okay, so look, if we calculate only a modulo, this operation cannot be inverted. So we are not able to guess what was the original value, because calculating let's say 11 modulo 5, we get value 1. So we don't know whether it was 1, 6, 11, or 16. Yeah, so there are no, we cannot decide. Yeah, so this operation is not invertible. But the rule is that when we prepare data and we calculate modulo N, so we get Ci. Is it true for all of you that that you cannot or you have bad audio. That is something new. Okay, I hope it will be okay. If something will be wrong, I record it so you can even listen it again. And because I recorded locally, there are no problems with, audio chopping. Okay, so look, if we have the block of data and we exponentiate it and calculate modulo n, so we get Ci, so we get value, let's say maybe not like this, but some value. And then to decrypt it, we have to take this block of data and exponentiate it with the value d and calculate modulo n, and we get mi. So look, in this process, we can encrypt and decrypt data. But to encrypt data, we have to have this pair of values. To decrypt the data, we have to have this pair of values. Yeah? So look, even we have data which were encrypted and we don't have the value d, so it is unknown, we cannot decrypt it. So this process requires, or is not, symmetrical, because to decrypt, we have to have different pair of values, and to encrypt different pair of values. Okay, so look. One of this key is called private key and other is called a public key. In fact, which one is public, which one is private, it depends on some agreement, yeah? But the key thing is that the private key cannot be published, so cannot be given so it can be given to no one. Yeah. So you should keep it secure, but public key you can send to everyone. So look, now I try to encrypt data. So we have hello Alice, and Alice using KA. So let's say this is my K. So this is my key A. This one is B. So he encrypts data using N and E. So here we have something which is called or denoted as CI, so encrypted data. So data are sent to data is sent to Alice, and Alice using key B, it tries to decrypt it because she has this value N and D. So finally, it can read hello Alice. But let's say that here we have a bad guy in the middle. So he knows what is the public key. Sorry, here I make a mistake, because according what I said before, this should be a public key and this A should be a private key. But okay, hope you you know, or you can understand it. But look, here we have a bad guy in the middle. So when the public key was sent to Alice, it can use it also, because this key can be read or intercept. So even this data is encrypted, the hacker can decrypt it as well as the Alice can. So, but what is the benefit of using this data? Even it is able to decrypt this data, it cannot to modify them. So let's assume that someone sent you know, information that, okay, I sent some form or request or something like that. And if I encrypt it or signed it using my private key, everyone can read it, but no one can modify it. So even you have a public key and you can decrypt this information, you cannot modify it. But because to modify it, you have to decrypt it, make modification, and encrypt it using private key. But private key is not accessible. So probably you heard or use a digital signature, and it works like this. So it confirms that this message or this document was signed, let's say encrypted, by us. So everyone can read it, but nobody can modify it. Okay, not nobody, but nobody who don't have a private key. Okay, so this is the clue information. The second feature is that Alice is able to encrypt data using public key. So she can use this method to encrypt her message and send it to me. And in this case, nobody can decrypt this message, only the person which has a private key. So look, I can encrypt data with private key and decrypt it using public key, and opposite, I can encrypt data with private key and I can decrypt it using using public key, using private key. So this is, you know, let's say invertible. So if Alice sent message which was encrypted, even there is a man in the middle, it cannot decrypt this message because he or she don't have the private key. So this method is the base method for TSL-SSL protocol. So it is used to encrypt messages which are sent between server and client. But what is the security issue here? So, okay, if I have private key and I can encrypt data using this private key, everyone who has public key can decrypt it, but cannot modify it. But there is a particular or certain risk. So let's say that we have a client and we have a server, and here we have man in the middle. So this is a kind of security issue or attack which can be performed when the communication between client and server is encrypted. So look, usually the pair or the public and private key are stored on server side. So the server has private and public keys. So when the client connects to server, server sends a public key to client. So it can be also captured by the hacker. So what can be done here? Okay, in fact, it can be performed like this: that when the communication is intercepted or can be intercepted by someone in the middle, it can take a public key here, but it can also send another public key. So it can have its own private and public keys. And instead of sending the server public key, it can send its own public key. So in this case, the communication between client and man in the middle is encrypted using different pairs of keys. So the hacker is able to decrypt all messages which are sent to client, and then it can repack them and encrypt it using a public key of the server and sends it to server. So in this case, there is a risk that something will be modified by hacker. So let's say you have your bank account and you want to send money to someone else. So the hacker is able to modify the received bank account number, yeah, for example. So how we can protect against it? The protection which is used is using something which is called an authorization. So we have the something which is called CA, so certificate authorities. And when I connect to server and I get a public key of the server, I can verify it whether this public or this key was issued for this server. So CA is a third, third party or the third side, which can confirm that the key is legally issued for the server. So in this case, when there is a man-in-the-middle attack, the public key is different than the key which was issued for server, so the CA doesn't confirm it. So this is the first thing. So if I try to, if I will try to oops. Okay. So HTTPS. Okay, so look, I used HTTPS connection. Maybe first I will show you mBank, yeah? So look, this connection is secure. So here you can see a log, and when you click on it, you can see that connection is secure, certificate is valid, it is issued for mBank, and you can see some details of the certificate. Here, I connect using HTTPS too, and there is a message, your connection is not private. So what does it mean? It means that the certificate seems to be invalid because there are no, the CA, so certificate authorities, doesn't confirm that this certificate was issued for a certain domain. So in this case, okay, there is a risk that someone modified, or there is a man-in-the-middle attack. But there is also another explanation. Because if you want to have a certificate which will be confirmed by CA, you have to pay for it. It's about, let's say, it depends on the certificate type, but it's about 25 euro or 30 euro per year, yeah? So you have to pay for it. Of course, if you have, bank side, it's worth to pay for it, yeah? Because, but if you have your own server and hosting, okay, sometimes you don't want to spend 30 euro per year for it. And you generate this certificate by your own. So it was done in this case. So I have generated certificate by my own, and therefore it is not confirmed by CA, but it is used to encrypt and decrypt data. So even there is a certain risk that there is man in the middle, that data is encrypted. So it's still better than using connection without HTTPS. So if I use HTTP, okay, there are no information that, okay, there are some, okay, not secure. It means that there are no HTTPS because we use standard HTTP. But I can log in, I can enter my password. But last time I showed you that even my password here is not visible. It is sent using plain text. So it's better to use certificates, even they are not confirmed by CA. Of course, if this message about security issue will be visible on your bank account or your email account, it means that something is wrong. So it's better not to proceed. So you should verify whether your address, whether your certificate is okay, and stop connect to this site. Okay. Okay, so here you have a scheme of man-in-the-middle attack.
Excuse me, teacher.
And how it works. I hope that you understand what is the clue here. Of course, there is issue how we perform this attack, so how we can,
Excuse me, teacher, do you hear me?
Enter in the middle of this connection. I will tell you about this issue more general, but let's say it is possible. In some cases, it is quite easy.
Excuse me.
To do.
I don't know if everything okay is connection, because I have a question.
So I'd like to tell you about some man-in-the-middle attack stages. So how the hacker can, enter in the middle. There are several possibilities. Of course, it's the knowledge which is not so. It's these kinds of attacks are well known. So I showed it or presented to you, not to use it by your own, but to make you some to give you some knowledge how we can protect against this kind of attack. Yeah. So the first method, which was discovered, I think 2 years ago, it is called crack attack. So here you have a short movie. And I'd like to comment it. Hope.
So on Monday, the 16th of October, 2017, two researchers at the Belgian.
Okay, something is wrong. Wait a moment. Can you?
The security mechanism used on all major Wi-Fi.
Yeah, I can see it. So today is something wrong with. Okay, so maybe you will. You can look at this movie by your own. But I'd like to tell you how the crack attack was performed, and more detailed description you can find. Mr. Vladimir, I will answer your question about quiz at the end of this lecture. I think today we don't have quiz. The quiz answer tomorrow, so don't worry about it. Okay. So at the end of this lecture, I will answer your question. So this attack was performed when we tried to connect to Wi-Fi hotspot. So it may happen, let's say, mostly in public area like restaurants and other place. And this attack was due to some vulnerability in a way how connection was negotiated between your computer and access point. It was somehow embedded in protocol, so it was a feature of protocol. So it was not not easily, not a bug, but it was a feature. So more detailed explanation you can find in this video. But what was the problem here? In this case, even I tried to connect with hotspot, there could be someone else which, let's say, somehow mimics this hotspot. So I connected to his computer, and then it connected me with hotspot. So in this case, it was the first method for man in the middle. So all data which were sent to hotspot was first directed by the hacker computer or any other device. Okay. This vulnerability was partially solved, but okay, but more detailed information you can find here. The second method is called ARP spoofing, and I think it's quite can you see presentation or not? Okay. So the second method is called ARP spoofing. And now I'd like to tell you about ARP spoofing, but because it's quite, so it's closely connected with the topics we have last time. So ARP protocol is used to discover hosts which are present in local area network. No, it's impossible to run this movie. Okay. Here we have several interesting slides. I'd like to show you, and you can watch this movie by your own. So first issue is that in okay, is the audio chopped now? Okay, so look, the first issue is that the communication in a local area network is performed not using IP address, but using medium access control, so MAC address. And okay, so when our computer connects to network and it sends data to particular node, and it has the address, IP address of this node, it has to discover the MAC address of this node. So to discover it, it sends or it uses a ARP protocol. So it sends special message or broadcasted. So it is sent to all the computers in networks, asking who is the or who has the IP, and the IP is sent in this or published in this message. Contrary, when a new node is connected to network, it broadcasts using ARP the information that, okay, I'm a new node and my IP address is, and my ARP address is. So the other nodes are able to store it or cache it. So they have ARP table, and when they want to send data to particular node, so to IP address, they are able to transform it or take the MAC address. So they are able to send it using MAC address. Look, here I have the ARP information. So I have MAC address of the router I'm connected now, and its IP address. If there will be another nodes in this network, I will see more entries here. So if the IP in my local ARP table, there are no entry which connects IP with MAC address, the ARP message is sent. Okay, so my computer try to localize particular node in the network. So how ARP spoofing works? So there are two methods. The first method is that a new node tries to send information that I am a new gateway. So my IP address is like that, but my MAC address is, different. So in this case, if someone sends or try to update the gateway MAC address, all messages which are intended to send outside will be sent to this node. So it requires that particular computer should be connected to local network, but it's enough to, to swap the MAC address for computers I want to attack. So then all messages are sent via the hacker computer. So this method is called ARP spoofing. Of course, switches and computers are usually protect against this kind of attack, but it can happen. There are several stages which can, proceed or be before this attack, like ARP flooding. But it's not the topic for today. Yeah, but I want you to understand that it may happen and it can be performed both in, Wi-Fi network as well in any other network like local area network, that someone will intercept the connection, so it's enter in the middle between a router and between my computer. So we should be very careful, especially when you use your computer in public places using public access points. Okay. Of course, there are other attack types which are quite popular. One of the very commonly used attack is DDoS, or so denial of service, or distributed denial of service. These attacks are performed. They have several goals, but they are performed mostly on servers, not on client computers. The first goal is to make particular service inaccessible, because there is a lot of requests which are sent to servers. So this is the first possibility. But the second is not to make it, not accessible, but probably you could observe that sometimes when you connect with particular website, there is a message that the service was moved, and we are, switched to another website. So some attacks, which are called denial of service, works like this: that the information that the service was moved is sent to computers, and let's assume that the computer, there is some, there is a chance that the computer tried to connect with this service just before. So it waits for the answer of this of the server, but it gets, information that service is not accessible. It was moved to another website. So if there is a short delay between this message and the computer request, the computer can switch to this new address. So in this case, it connects with this address, so hackers can somehow tries to exploit this computer. Of course, when the denial of service attack is performed, the hackers performed it, blindly, because they don't know whether this computer connects with particular service, but these packages are sent, quite often, not so often because in this case it can be detected by firewall rules, but they are sent quite often. So if it takes, let's say, weeks or months where this attack is performed, the risk that there will be, a short delay between the request and this falsified response of server, the probability increase. So in this case, our computer can connect with particular or with a server or fake server, yeah. How we protect against this attack? First, the first issue is you should turn your computer off if you don't use it. Yeah? So it's the first issue. The second issue, yeah, it's good to have a firewall which, not only filter filter traffic, but it analyzes some unexpected behaviors. So firewalls usually performs statistics, and when the amount of packages of certain type increases, it means that there is a risk in DDoS or Smurf attack. But the most commonly used attack is phishing. Do you know what the phishing attack is? Yeah, so in case of phishing attack, the problem is that we send our passwords and credentials because we think that, okay, there is our website. So there are no good protection against it. So automatical protection, because if you read your email and let's say that your for example DHL shipment was stopped because there are no, also we have to pay additional money for it, okay, and you pay for it, or you even publish your credit card number, okay, it's your problem, yeah. You should be very careful to publish your private information. Yeah? Okay, so this is commonly used, and looking at the attacks which were performed on, for example, on Sony Corp or on FBI, CIA last year, all of them were based on phishing. So the human factor is the weakest chain, usually the weakest chain in this security system. Okay. Yeah, I told you about port forwarding. Okay. Yeah. Okay, so I think that the last issue about how about computer network is something which is connected to programming, but during the lecture I'd like to show you or tell you about this only as a theoretical issue. But during your laboratory classes next year, you will practice it. So you will create a client-server application. So now I'd like to tell you how we can create the application which let us to communicate between two computers. There are two possibilities. So let's assume that we want to write a program which performs a chat between a number of users. So if the initial approach which most of you will apply is that if I have several computers and I'd like to send message, I have to connect with this computer, with this computer, with this computer, and send the message. Yeah? The other, but look, if we have many nodes in this network, you will see that it starts to be a little bit too hard to maintain all connections, because if I have a new node, all nodes has to connect this new node. So it's a little bit hard to maintain connections, to update messages, or to update the messages history, and so on. So this type of connection is called point-to-point or peer-to-peer connection. Now I'd like to tell you about the more efficient architecture, which is called client-server architecture. So in this case, when I have several hosts, I have a server here. So every host has to connect to server. So hosts are not connected directly. So in this case, when I publish a new message, it is sent to server. If another host wants to verify whether there are new messages, it has to request the server whether there are new messages. And as a response, server is able to send these messages back to him. So look, everything here is stored on the server. So if I connect a new host, it is able to download all messages from server. So it has access to all historical data. Okay, it depends, of course, on server side. The second issue is that if we have peer-to-peer connection, there is a problem with in authorization. So how we can confirm who is allowed to connect to our computer and so on. But if we have server side, in server side, the authorization rules can be equal for all of them, and they can be, you know, locally, or they are stored in a single place. But the client-server architecture has some, you know, limitations. And now I'd like to show you how, what are the limitations, what is the difference between client's server architecture and peer-to-peer. So look, we have two different applications, so they are distinct. They are not, you know, like in peer-to-peer, we have single application, and it can be, you know, used on different computers. Here we have a client application which can be used on every computer which performed a client side, and we have a single server application, which there is only the one application or one node of this type in this system. So first, the server is created somewhere and it waits for client connections. So when a new client or when the client connects to server, it can write and read data. But look, the first action is also always write. So it has to send request to get a response. So in client server architecture, the server is a passive site. So it doesn't start conversation. So let's say that my client published a new message. So the other clients will not be prompt that the new message was published until they don't request this information. So in case of peer-to-peer connection, we assume that we have something like full duplex. Yeah? So everyone in every time can, you know, send a new data. In case of server client-server architecture, the server waits for requests. If there are no requests, nothing will be sent to client. So in this case, the client has to poll server, let's say once per second or once per minute, to verify whether there are new messages for it. So this is very important. But when we connect to server using, for example, TCP protocol, this connection is established permanently, so we don't need to close it. So in this case, we can write and read data without connection because we are connected. And when we decide to disconnect, we close connection, and to connect again, okay, we have to perform this stage. Okay. So this is the method how the client server connection works. I think it is enough for this topic for today. So I will start a new topic now, which I will continue to tomorrow. And tomorrow we will finish talking about computer hardware. So the next 5 lectures will be about object-oriented programming. So we switch to so we go back to programming again. Okay. So this lecture, so the last lecture, usually I have two topics more about hardware. So the one topic was about processors, and second topic was about graphic cards. For processors, one lecture is not enough, so I will skip it. So there will not be so there will not be lecture about computer processors, but there will be lecture about graphic cards. And when I will be talking about object-oriented programming, I will use some examples about OpenGL library to show you how we can use OpenGL in programming. Okay, where is my mouse? Okay. Okay, so about tomorrow. Tomorrow I'm planning a quiz about computer networks. So and maybe there will be a single question or 2 questions about the computer graphics. But they will not be so detailed as it can be on during exam. So I only want to verify your general knowledge about these topics. Okay. Okay. Okay, so now I'd like to tell you something about computer graphics. So this topic covers several issues. So the first issue is how modern graphic cards works. So probably most of you okay, Mr. Vladimir, about exam. We have to arrange exam, so or schedule it. In fact, it's up to you. I don't know whether you have some plan for your exams or not, but we can arrange a particular date, and for me it's okay. So in general, I'm accessible in February. So try to, arrange something by your own, and give me two dates, and I select the date which is suitable for me. Okay. Okay. So now I'd like to tell you how it works. We start from math. So I'd like to show you what is the application of matrices. Probably you know that graphic cards has many arithmetic units, and they are specialized in matrix multiplication. So they can be used not only for graphics, but also to mine bitcoins or any other currencies. But let's start from basics things. So look, if we have the object, so rectangle here, it can be presented using different parameters, but we can represent it using let's say in this case 2 points. So we have point xa and let's say point A and B. So every point has 2 coordinates, but when we have 2 points, it's enough to draw this rectangle, provided that it's not rotated. Okay. The position of B and C are dependent. The second possibility is to represent a rectangle using the position of its center, so center point, and using the dimension, so using A and B. So there are 2 possibilities how we can represent rectangle. Of course, we can switch between these 2 representations, so they are equal somehow. Yeah, I hope it's quite easy. So now I'd like to tell you about transformations. So let's assume that we have a rectangle which is represented using center, and we have all the vertices here, and we want to transform it. So we want to rotate it. So in fact, to rotate a rectangle by angle alpha, it's enough to calculate a new position of every vertex. So if I have vector which connects the vertex with rotation center, it's enough to rotate this vector, and I can perform it for other vertices too. So if I calculate a new position of every vertex, it's enough to connect them. And we get an object which was rotated. So it's enough to calculate it for particular vertex and repeat it for other vertices. So look, here you have the expression which let us to calculate a new position of xa prime and y prime coordinates when we rotate by angle alpha. So looking at this expression, you can see that here we have a fixed block. So we can represent it using a matrix operation. So here we have cosinus minus sinus. So we have cosinus alpha times xa. Yeah. So here, this is the first term minus sinus alpha times ya. So this is the second term. Yeah. And again, so look, here we have the vector which is represented using coordinates which are represented using vector. Here we have something which is independent on the vector, but it is called a rotation matrix. And finally, we get the vector which represents the new position of the A prime. So look, this different methods how we can represent this expression, but there are some benefits. So look, if I have a rectangle here, I have to repeat this process 4 times. If I have, polyline, I have to repeat it more times. So look, the rotation matrix, it doesn't depend on the vertex. So it depends only on the rotation angle. So it's enough to calculate it only once at the beginning. So when I calculate it, these values are fixed. So I don't need to calculate cosinus, sinus every, in every multiplication. I do it only once. So in this case, I can perform this operation quite often, quite easily and fast, because most processors has specialized units which let us to multiply vector by matrix. Okay, so what about translation? So if I want to translate object, it's enough to sum 2 vectors. So I can, for example, I have translation vector xc, yc. So to calculate a new position of vector A, it's enough to sum this vector up. So to sum the corresponding coordinates. So now I'd like to tell you something which is the essential thing for for computer graphics, and not only computer graphics, but also robotics. But it is quite commonly used in computer graphics too. It is the way how we can represent vectors and transformation to perform them in homogeneous way. So look here, to translate, we have to add 2 elements. To rotate, we have to multiply it. And when we are talking about homogeneous transformation, we want to represent translation and rotation using the same, formula. So first, in homogeneous transformation, the vector is extended by a single term, which is always equal to 1. So in case of 2D case, we have x, y, 1, and in 3D case, we have x, y, z, 1. In this case, the translation matrix looks like this. I have the I matrix here, but these terms are dx and dy, so they corresponds to translation of the vector. So look, if I might multiply it, so I take this vector, so I have translation times, let's say, x, y, 1, and I multiply it, I get something like this. X times 1, 0 times y, plus the x, y, so y plus dy and 1. So I get a new vector, new position, which was increased by dx dy. When we have a pure rotation, it looks like the same. So we have the rotation matrix here. The translation term is equal to 0. So I have x times cosinus alpha, y times minus sinus alpha. So it's like in previous case. So like here. So look, here I have the single matrix which can represent both translation and rotation. In 3D case, it looks, similar. Yeah? So here, when I rotate it around the z-axis, the z factor is equal to 1, and the rotation matrix block is here. Okay, but this method has a very important feature. So let's assume that I'd like to perform not only a single transformation, but I'd like to perform several transformations in a sequence. So first, I have my original point, and I'd like to rotate, to translate it, and then rotate it. How to represent it? So look, I have A prime, which is translation of the A by vector dx dy. So it corresponds to moving the coordinate system to this point by vector dx dy. So I get A prime. Now I'd like to perform rotation of the A. So look, to perform rotation, I have to take rotation A prime, and I get ABs. But if I substitute this value here, I get, okay, it's wrong. It should be switched. So I get the expression that ABs is equal to rotation alpha times translation dx dy times A. So look, this represents the a joint transformation. So so look, rotation alpha, when we have two-dimensional case, is a matrix 3 by 3 elements, and it looks like this. The translation is a matrix 3 by 3 elements, it looks like this. So in fact, I can, because they are two matrices, I can calculate a single matrix which is equal rotation times translation, and I can apply it to calculate the resulted transformation. Assuming that it is equal to rotation times translation. I hope you know from your math classes that if you have two matrices 3 by 3 and you multiply them, you get the resulted matrix, which is also 3 by 3 elements. So look, it doesn't matter what is the number of operations you performed, the resulted transformation matrix is always 3 by 3 elements for two-dimensional case. It can represent any complex chain of transformations. Of course, remember that the order of transformations you perform, so if you perform translation first and then rotation, the result will be different than if you perform first rotation and then translation. Hope it is obvious, but it doesn't matter. Always you can create a single matrix which represents all the transformations. Okay, so I think that's all for today. So thank you for your attention, and we have tomorrow we have only a single lecture, yeah, and just before the end of the lecture there will be a standard quiz. Okay, so thank you and goodbye.